Okay, here I am again. Hi everyone. Hello and welcome. Microbehunter here.
Okay.
And the sound seems to work as well. I think, as always, I'm trying to get everything set up a little bit. So just a second. Give me a second here. Okay, I think we're ready to go. Hello and welcome everyone again, and to another Saturday live stream, Saturday microscopy live stream. Yeah, I think that everything seems to be working right now, and what you're able to see here right now, just in case you're wondering, the to Daphnia, to water fleas, which I'll be looking at today under this, kids microscope here as well. Right now we're looking at it with my regular, the big microscope. And I would like to also talk a little bit about the Foldscope. So just going to show you the desk. I'm just going to give you a quick run through the topics today. Yeah, this here is the Foldscope. It's a paper microscope with a difference. It's not made of paper, but actually of fairly high quality plastic foil. Okay, I would like to talk about that as well here. And a couple of other smaller things is from last week. You might remember this microtome. I would like to give you a little bit of an update concerning this microtome over here, and a tool that I bought for this microtome, and a few other smaller things. If you have any questions about anything microscopy related, please feel free to post it in the chat. Many of you already know that. And please, if possible, also add an @Oliver or @Microbehunter in the front, so that I know that the question is directed towards me, because sometimes people in the chat will also communicate with each other. That's perfectly fine, but then it makes it more difficult to find the questions. And again, just like last week, I will not be answering questions throughout the first hour. This is where I'm just going to talk a little bit about the topics that I want to cover. And then after 1 hour approximately, I'll be talking about the questions and trying to answer them to the best of my abilities. So first of all, as always, it's been a custom and tradition that you kind of just briefly mention from where you are. I'm just going to say hello all around the world. I think I take it from your comments that essentially the sound seems to be working. So I will be starting off right now, and I'm going to talk first a little bit about the Foldscope. And if you're interested in this Foldscope, I did a couple of years ago, as a matter of fact, already got it. And I put a link into the description below to a review video where I'm doing a complete unpacking and assembly. I'm not going to be doing that. I'm just going to show it to you and what it actually is. It's a nice, I would say, a nice project, also suitable for schools, education, and I think it's also a nice present for people who are interested in microscopy. It is a paper microscope, but as I mentioned, it is not really made of paper, but it's actually made of plastic foil. You might not be able to see that, but this is not cardboard. This is actually plastic. Okay, so it's very strong. Okay, and it's a single lens microscope, a little bit quite similar to the Leeuwenhoek microscope back in the day. The first person who discovered the microscopic world, Anthony van Leeuwenhoek, from the Netherlands. He made single lens microscopes, and this is also a single lens microscope. Of course, you see the lens over here, and it is suitable for actually looking at objects by putting a slide. Like, for example, these are here mosquito wings under in here. Unfortunately, I'm not able to actually show you how it looks like, because I'm not able to put a camera in here. I tried it with a mobile phone, but even that didn't work. And what you have to do is there's a magnet here, there's the lens over here, and what you do is you try to insert the slide in here. Okay, there's a little slit, if I'm able to get it. Okay, and what you do is you insert it in here, and also on the other side. Okay, it has to slide in all the way here, and here as well. And it's held quite nicely in place. And then what you do is the following. You can then move. You look through it here, and then you can basically move the slide around, both X, Y, okay? And the slide is here in the back, obviously, and then this by moving moving it back and forth, you're able to find the object that you wanted to look at. And this one is quite a fun thing here. This here is actually a focusing system. Because if you push it in, because you see it's kind of a conical, it's thicker over here than over here. And when you push it in, it pushes the lens away from the slide. So you also have a focusing system built in here. So you can actually do some basic microscopy using this system. You have to hold it against the eye like this, and then you're able to look against a bright surface. I think it's a fun project. It's a nice present, as I already said, but of course it's not going to replace regular microscopes. It's also not meant to do that, right? But I think it's a very interesting idea, and I just want to show you how it comes. Here, when I ordered it a few years ago, it actually came with quite a few. It was a nice little. There was a nice little pouch included as well. The instructions are very extensive as well. So well documented everything. So they spent quite a bit of effort in documenting everything. So I would say it's also a nice afternoon project to do a little bit of assembly and putting it together. But as I mentioned already. If you want to do real, in quote unquote, real microscopy, probably you would of course buy yourself a regular microscope. But I kind of still like this because it kind of shows how still quite a bit of design went into this whole thing here. So that you can move it X, Y, and even the focusing system. So just wanted to share this. There's a magnet here, and then you can also do it like this. So just wanted to share this with you as a possible idea for a rainy weekend maybe that you might have. So it's just that's pretty much all I wanted to share with you. If you were interested in this, then I did actually make it. I made a more extensive video, as I mentioned already before. The link is below. Okay, and I'm just seeing as well there are actually different versions of the Foldscope as well. Somebody's just mentioning it that there are the different versions of this. So maybe, as a matter of fact, maybe it's a good idea to maybe also try an updated version. Okay, because I think this seems to be version 1.0. Quite nice. Okay, and came with quite a lot of documentation as well. So what I'm going to do now is I'm going to put this away, okay, and I'm going to now move on to the next topic a little bit, and that is this kid's microscope, and I would like to simply talk about that a little bit, and there's also a reason why I want to show it to you. Let's move this a little bit further away. So, I mean, there are many of those around. It's called the Omano Junior Scope. I put a link to the company below. A couple of years ago, they sent me this microscope to do a review, and I also made a review. I think I forgot still to put the link to the review also into the comments. I will do that later. Okay, and it is a fairly low cost, sub 100 euros. I think it's around 60 to 80 euros or 60 to 80 US dollars. And it's a kid's microscope, and it's also marketed for kids. Okay, no condenser, only one focusing knob, no XY mechanical stage, just stage clips, fairly small objectives, even though they are actually made of metal. So actually a lot of parts are actually made of metal. The eyepiece I removed because I'm going to be inserting a camera, and I just wanted to show you a little bit. How one of those objectives actually compares. I mean, I don't have to take it out, right? But it is basically made of aluminum, and I just want to show you how this 10 times objective actually compares to a full size, a real one. I mean, it's a huge difference already, right? But the image quality compared to the price is still surprisingly okay. You cannot expect miracles here, but I simply want to show this to you. As well, and just for a little bit of fun, also with the intention, that's also maybe one of the reasons why I want to show it to you is some people are kind of wondering, I mean, what microscope do I need, and what features do I need, and can I even afford it? And I'm just saying, generally I say, if you have not started yet with microscopy, and if you're interested, just buy yourself a very cheap microscope first, not a toy microscope, but a cheap introductory microscope, and then you'll see if you'll be interested in microscopy or or not. And I'll be attaching this one over here. This camera is a little bit, how do you say, a little bit different than the other microscope cameras that normally you have. That's an industrial HDMI camera. So the resolution is not very high. There is also no possibility to actually store anything on a chip card, also not needed. And it simply delivers an HDMI signal out to my computer, right? And I've got a capture card. And over here, you've got, this is a so-called AC mount. So it's for industrial cameras. And what included up here is some reduction optics that I got from another microscope camera. Okay, and I connected this, and this is now has the same size as an eyepiece, and I'm now able to insert this into the microscope instead of an eyepiece. Okay, so this is how the setup looks like. By the way, this is also the camera that I've been using up to now for my stereo microscope. I simply took it out from the stereo microscope and inserted it here. And I want to therefore show you now how the images look like. Okay, so just to do a little bit of comparison here. And now you won't be able to see the microscope properly. It's standing here. And what I will do now is I'm going to switch over now to this view over here. Okay, so this is actually the wrong image up here. So what I need to do is I don't know. I should have actually thought about this earlier. I'm going to remove the camera. I don't know if this is... No, I don't have a place. I don't have a place to put it. I just realized. You know what I'm going to do? I'm just going to leave it there. But I'm going to actually turn off I'm going to turn it off. Okay. So otherwise people getting confused. And I'm going to switch on the lamp. Where's the lamp switch? Okay. That's the top illumination. That's from the bottom. Okay. The arrow I don't need, and I'm going to now show you. Let's have a look at these are the two water fleas, the two Daphne, and let's see how they look like in the small microscope. Okay. So let's switch over. I'm going to take now the slide, and I'm putting it now directly on the stage. Okay, and this is the lowest magnification. Okay, and this is how it looks like. Okay, and you know what, I might fix it using one of the clips here. The camera, there's a question, how much was this camera? I forgot. Honestly, I forgot. But I think I did make a review video in my other channel, and there should be a link to it. Okay. It wasn't that expensive, but I chose the HDMI camera simply for the reason that I don't need high resolution. All I need to do is I need to be able to use it for these live streams. Yeah, so that is basically how it looks like. Okay, and there are a couple of things that you already noticed. First of all, okay, I mean, we're able to see it quite well here. A couple of things that we do notice is, and this is not only a question of the microscope, but also of the camera, that the dynamic range is a little bit lower than what my other camera has. I wanted to explain what dynamic range is, because many people think, a good camera needs to have a high resolution. But what I'm actually interested in is also dynamic range, and dynamic range is the difference between bright and dark objects. So for example, we're starting to lose a little bit of resolution and image quality here at the dark areas. Also here, the eggs here in the back of the water flea are a little bit dark, right? So this, there is always a little bit of a trade-off, but otherwise you're probably going to see this actually looks quite okay. It's quite a usable image that we have. I'm just going to turn it up a little bit more. I can of course also adjust a little bit the properties of the camera. I don't know how to do that now. Configure video. Yeah, I'm able to adjust the brightness as well a little bit here. Okay. Yeah. You get the idea. Yeah. So this is actually how it looks like with the 4 times. I'm going to go up now with the magnification. This is now the 10 times. I have to refocus again. Okay, and this is how it looks like with the 10 times. So you see that it seems to magnify significantly more than, and it does, than my other microscope. Now, why is that? And this is a very common question where people ask me, what is the magnification that you're using? And it says, well, I can only tell you the objective that I'm using. It's a 10 times objective right now, but it will look different on the different microscopes because it depends also on the sensor size. It depends on the intermediate optics of the camera, on a variety of things. Yeah? So you see, the magnification is depends on a variety of factors. Yeah? So this is the eye, and because I just have seen in the comments, yeah. So I'm going to move this. Yeah, this here is indeed the heart that's beating. Yeah, and these are the 3 dark spheres here. These are the eggs. Yeah, let me try to. It's easy actually to go down with the magnification again. I need to refocus. Here we go again. Yeah, and for those of you just joined, I'm just showing you this here using a children's microscope. Okay. However, I do have to say that if you actually look through the microscope itself, the image quality actually is still a bit better. And the reason is because the camera introduces some extra magnification. The camera also has a limited dynamic range, as already mentioned. So the image does look a little bit more crisp through the, when you look directly through the microscope. Yeah. So here, in one of my videos that I made a couple of months ago, I've actually shown you some of these Daphnias giving live birth. If you're interested in watching that, then please do check. And there's actually one, I don't know, there must be some, I think there must be another one somewhere over here. Here's another one. Oh, it's the same one from before. Here. Here. Yeah. I put them back later into my jar. Yeah, here you see that some of them are a little bit, quite almost ready to give birth. Yeah, so in the back here you see already there are some babies in here as well. Okay. Yeah, so that's basically how it looks like. I'm going to do the following. I'm going to now go up to the maximum magnification, which I think is probably already a little bit too much and exaggerated. But for the sake of demonstration, I'm going to do that in any case. Let me quickly fix and hold the slide again. Yep. So, by the way, I'm also using now a concave slide, basically with one with an indentation so that they're not crushed. So the slide actually has is hollow on the surface, so that there is enough space for the water fleece. So that's 4x, 4 times. This here is 10 times. Okay, we already had a look at that. I'm going to recenter everything now. Here we go. So, and I'm going to now go up to to 40 times. And this is usually the one where we have the lowest image quality. Yeah, and this is already difficult now to actually find, especially with moving objects, it's already difficult to actually find the things here. Let's refocus. See, that's the eye here, right? And you can see that the image here already looks a little bit, low in contrast. The depth of field is of course low. We do not have a proper condenser, obviously. But again, it looks better if you look through it directly, because the camera introduces a lot of additional magnification, causing the whole image to appear yet more blurry. Yeah. So, but that is the eye, right? And let's go back all the way to the original again here. And you see at low magnifications, the image is actually quite decent. Yeah. They're not moving. That's the thing. I just read one of the comments here. Is this because what I've done is I used the concave slide, and I used some spacer cover glasses, and I put a cover glass on top as well. Yeah, so they just have enough space that they're not crushed, but not enough space to actually move around. Yeah, so I've kind of limited their movement, so it's easier for me to observe. Yeah? Otherwise, it's not going to be easily possible. Yeah? So let's leave the Daphnia behind. And what I would like to do now is I've got a few more slides here, not of living creatures, but some permanent slides as well. Okay. But, you know, just again for comparison, let me put them again into my other microscope. And here it is. Yeah, this is how it looks in my, in the big microscope. If you want to add a little color, you can do this as well. Yeah, that's because of polarization filters. Yeah, or we can go up with the magnification yet further. And here the image quality is of course significantly better for a variety of reasons, not only because I have a better camera system, I've got also Köhler illumination, I've got plan objectives, and so the clarity is of course higher. However, I also have a larger field of view, so this basically means that I'm not introducing any additional magnification, and this also subjectively gives somewhat of a more clear image. Yeah? Yeah. Okay, yeah, I'm just reading a little bit some of the comments, but I'll try to answer them later. If you have any questions or comments, please do post them. Okay, I will pick them up later on. Okay, so but let's now do the following. Let's have a look now at a few other things here. What I have here is a permanent slide of stained bacteria. So many people are interested in observing bacteria. Sometimes they can be a little bit difficult to see. But what we've got here is... wrong microscope. Here we go. And I just wanted to show them to you. Again, this is a permanent slide. And here we really have to go up with the magnification. So this is a commercial slide of, unfortunately, it doesn't say which bacteria these are. But I think you get the idea. And this is not phase contrast, this is just regular, yeah, regular bright field. Okay. And those little, yeah, dots and rods that you see, these are individual bacteria. Okay, so this is, I'm now using my 40 times objective. This is now a 60 times objective, and you see it's pretty sharp. Of course, with a microscope I can play around with the condenser, but of course I would like to now know how does this look like with the children's microscope, right? Because bacteria are kind of difficult to observe. You see the Daphnia, they're always fascinating to look at because they're moving around, they're fairly large, right? But now we really want to go a little bit to the limit, right? And yeah, this will basically, I will take it out, okay? And I will now put it into the kids microscope, okay? And let's have a look here. Again, let's start to focus a little bit. We can also see already those tiny dots. So this is using my 4 times objective, 10 times objective. Okay. Well, we are also able to see them. And now the 40 times. And this is again the one where it's a little bit more difficult to see, and that's the best that I'm getting here. Okay, it does look a little bit, washed out. And if you have an image that looks like this, there is a very easy way to still improve the image quality, and that is by simply increasing the contrast in Photoshop or another picture editing program. This does miracles, really. Huh? Yeah, so focusing is of course a little difficult here, yeah, yeah, but we're still able to see them, right? However, these are stained bacteria, and if you want to observe live bacteria, then I would say that those children's microscopes are yeah, I've had real problems actually seeing them because the contrast is too low. I have some time ago also played around a little bit. What I've done is beneath the stage there is. I mean, I don't know if I can actually show this to you. Yeah, I'm going to. No, this is. I have to show you the desk view. I'm going to show you. Okay. Yeah. Here, beneath the microscope stage, there is this ring that you can turn, right? And there are little holes in the ring here, but actually they don't do anything. Yeah, they are far too large, but it's still useful because what you can do is you can add some filters in here, like polarization filters, for example, or something that I've also tried is I actually covered the hole here and I added a little pinhole, a very, very small hole. This really reduces the brightness a lot, but it also really greatly increased the clarity and also especially the depth of field. So you can actually see those holes here better, right? I think they're way too big. So they don't really have any effect. But if you cover them a little bit, and if you add a little tiny pinhole, then this would be like decreasing the aperture. So you can actually tweak the microscope a little bit around. So this is something that I just wanted to show you. There's also the question of dark field. Dark field is not possible, and the reason why it's not possible is because it doesn't have any. It doesn't have a condenser. Okay. So now what happened now? Now I have. Okay. Here we go again. Okay. So these are the bacteria. I would like to show you next. Let me quickly take this out here again, those Daphnia. Another thing I would like to show you next, and I need to get the Foldscope again, is I'm going to take out the slide that I have in here. Okay, remember I put a slide in here. Yeah, that's actually also one of the things you have to consider with a Foldscope. It only works with permanently mounted slides, because if you add, of course, a wet mount, then you're not able to put it in here because there's water all over the place. So these here are now our mosquito wings that I mounted a few weeks ago because I was growing some mosquitoes non-voluntarily, so to say. And let's put the mosquito wing here under. I need to change this. And lots of dust here. Here we go. So that's the mosquito wing. Again, at 4 times magnification. Okay. And let's go up again. Yeah, 10 times. And 40 times. Yeah, I moved it accidentally again. Here we go. So I think bottom line is those kids' microscopes, they work pretty well for 10 times and 4 times. Yeah, for 40 times it looks already kind of a little bit low in contrast. However, this can be partially fixed by actually improving the contrast again in Photoshop. Yeah. Okay. So here again we see the scales. I mean, I gotta tell you the following. You have to understand that folks back in the 19th century did real serious research with microscopes that were probably worse than the ones that we have, than a kid's microscope these days, right? So nowadays we've got modern optics, modern technology, and modern glass chemistry with different refractive indices and so on. So there's quite a we've gone a long way. Yeah? And even I remember back when I was still at university, back in the early 1990s, microscopes like these kids' microscopes, they didn't exist. Yeah, there were a whole bunch of toy microscopes, but they were really not very good. But those kids, introductory kids' microscopes, yeah, didn't exist at all. So I'm going to now show you this the wing under my other microscope. Okay, I have to switch over again here. Yeah, and this is how it looks like. I'm staying with bright field. Many of you know that I have got also phase contrast and DIC. I'm not gonna do that for comparison purposes. Yeah, I'm going to just stay here. Yeah, and I'm able to, of course, change the aperture as well. Yeah. Yeah. So, what else do I have here? 2 more slides. Then I would like to move on a little bit again. Let me quickly check what I have on my on my agenda. So last week I made prepared 2 algae slides as well. Just wanted to show you because we were talking a little bit about bubbles and then whether the air bubbles are increasing or decreasing. And that is essentially one of the algae slides that I prepared last time. Cyanobacteria. Yeah. And here some true algae. Yeah. So and I've used the PVA glue, the mounting medium, the PVA glue as a mounting medium. And I think we can see that the specimen seems to be doing quite well. Yeah. Again, this is because it's a permanently mounted slide, no movement visible, which is usually in water samples. You also want to see some kind of movement of water organisms. Of course, this is not possible when you make a permanently mounted slide, but then, yeah, at least you have the slide then for a longer time. This one over here, this looks very much like a pollen grain, this dark thing here. Okay, that here is an air bubble over here, and this looks very much like a pollen grain. Somehow got caught in yeah, yeah, in the filaments here. So that's basically simply to show you that those slides are also doing fine. What I usually then do is I'll print out some slide labels and supplied with a date and showing the specimen. Here we still got some air bubbles. This one looks a little bit messier. Yeah. But as I mentioned already, the water-based PVA glue is usually quite suitable, generally more suitable for water organisms like, for example, these algae here. Yeah. Other mounting media contain some kind of organic solvents, and those organic solvents, what they sometimes do is they will dissolve the chlorophyll, the pigment, the green pigment, and then this causes kind of like a bleaching of the specimen. They lose color because the color is dissolved away by the mounting medium. And if you're using now water-based mounting medium like the PVA glue that I've done here, then also the green chlorophyll will stay inside the cells, because the water will not dissolve the green chlorophyll. Yeah. So, so very quickly, just because I see it later on, I will answer the questions. CA glue can be used to make permanent slides. It's generally not a good idea because cyanoacrylate superglue will produce fumes, and those fumes will deposit. And if you are not careful, then those fumes will actually deposit even on the optics of the microscope. So if you want to experiment with CA glue, then you have to make sure that it's really completely cured before you actually put it under the microscope. And CA glue will actually cure not by drying a solvent, but by actually reacting with moisture. Yeah. So this means that if every object has a certain moisture, and if there is moisture present, for humidity, then the CA glue will start to cure. Yeah. So the mechanism is quite different. Yeah. Yeah. So this is something just, okay, so this is, and very quickly, because I promised you, let's quickly have a look under the kids microscope, how it looks there. And here we go. Yeah, this is how it looks on the kids microscope. Again, the somewhat lower dynamic range that we see here might also be due to the camera, of course, or most likely is due to the camera. Low dynamic range basically means that we're again losing some details a little bit in the darker and brighter areas. Yeah, looks a little bit posterized, so to say. Yeah, and yeah, we can go up a little bit with the magnification. And still, I think it's quite okay. I mean, it's very useful. And here we've got the other slide here. Yeah. And this is how it looks here. Yeah. Focusing requires a little bit more patience here because we only have one focusing knob. But yeah, you see it's usable for most specimens, and yeah, I think can be a low cost and fun start into the hobby. Yeah. So, what I would like to again remind you, if you have any specific questions or comments, please feel free to post them in the in the comments section. Okay. After approximately 20 minutes or so, 25 minutes, I would like to go through the questions, and I will try to attempt to answer them. So I'm just putting the camera back to my stereo microscope, and I would like to now move on to the next topic. And that's kind of, for those of you who have been following now for a couple of months now or weeks, whatever, you might have noticed that I'm now starting to talk about several topics and keep them a little bit shorter. But I wanted to show you, just also share with you not only the successes, but also the problems that I have, because sometimes even I'm getting some interesting tips also from the community. And last week I showed you this microtome, with which I'm very happy. Okay, so I'm not going to go into a lot of details here, but the thing is if you want to get good cuts, you have to make sure that the specimen or specimen holder or the carrot that you use has to fit tightly into this well here. And I got an email from one of the community members who actually made some recommendations. Thank you very much. And what I did is I bought myself this here, a hole puncher. Okay, so this is 26 millimeters across. This is 26 millimeters across, and the diameter of this well here is 25.5, I think. Yeah, so it's around 1 inch across. Yeah, and the size of this hole puncher is slightly bigger. Yeah, and what I've tried to do is I try to punch out carrots and potatoes to make them fit into here so that I'm able to cut the specimen. And I've been trying with carrots and now also with potatoes, and I just want to share with you some of the problems that I had. Basically, again, some of the issues, and that is the following. Look at this here. I tried several times. You have to be really careful because when I'm punching, sometimes there is this horizontal drift, and then I'm not getting a nicely shaped cylinder, but one that's a little bit, going off to the side. This here as well. This here as well. It's actually happened quite frequently. I tried to punch it, right? And then you're kind of moving it, and then it goes off to the side. And then, of course, this is not usable. Okay, you have to make sure that it's really properly vertical. So I'm still working on this a little bit on actually optimizing the making of these cylinders here. Yeah. But otherwise, it works quite nice. I also ended up breaking one of my plates today because you should do it on a proper cutting board and not on a dish. But I ended up breaking one of the and because of this, and if I tried to also maybe by going around in a circle like this as I was punching, but this is also a bad idea because if you kind of try to punch the potato going around in a circle like this, then actually it will cut the potato or the carrot smaller than the diameter of the hole punch. And that's of course also not the point. Yeah, you want to make sure that it really has the same diameter. Yeah? So with carrots, it kind of worked a little bit better than with the potatoes, but it's still something where I'm practicing a little bit. Yeah? I've also tried to, basically I've also tried to use, I don't have one here now, I also tried to cut this using razor blades, also not very workable because razor blades are flexible. So for cutting the specimens, you have to use something which is a knife that is fairly rigid. Okay, so that's also something that I discovered. So I also tried different knives here, but for right now, I'm going to stick with those here. Yeah. So this is the So just to keep you a little bit of updated, this is something that I'm working on right now. But generally, I'm quite satisfied with the results that this microtome delivers, especially because I like the fact that it starts to snap in. Okay, so I'm able to control this in a very precise way. It's also a very compact microtome. Yeah. So just wanted to keep you updated. I keep on working here on this, and I'll inform you if I'm a little bit more successful. Yeah. So I want to now show you for the next one. I want to show you a couple of pictures. Okay, I'm just reading comments again. I want to show you a couple of pictures right now, which somebody sent me. Thank you very much to Brian. Okay, and he has been looking for micrometeorites. So I'm switching topics again. And if you also have some pictures or small video clips to share, then please feel free to send them to me. And thankfully, Brian gave me the permission to show the micrometeorites to you. He did some image stacking. Okay, and they look pretty cool. Okay, so micrometeorites is basically cosmic dust, yeah, and they can be collected using magnets, they look quite nice here. And he basically sent me those pictures, and he basically took images of different focal, different focus, and then he stacked them together to produce an image which is in focus all the way through. So this is actually quite a nice thing, and this is also his setup. I'm going to maybe pause here a little bit. How do I pause this? I need to pause this up. I need to go back one here. This is his setup, which is quite interesting as well. Need to explain this. How do you make sure that there is even illumination from all sides? And that is something where this is the microscope objective, of course. He put some kind of a transparent, either paper or plastic cylinder around it, and strong lamps from all sides. So this acts like a diffuser, and this ensures that there is even illumination from all sides. Yeah, so that's also shows a little bit that you do not need a stereo microscope to do epi-illumination, but that you can actually use also regular low-power objectives. And I've also been doing that, but what I like here specifically is the setup to ensure that there is a strong, even illumination from all sides. Yeah? So this is simply So thank you very much for giving the permission to share the images here. Okay, I go on, and the slideshow starts to loop again, and here we are again at the beginning. Yeah, I think if I understand correctly, not all of the micrometeorites are metallic, but the metal ones can be quite easily extracted. I also have a couple of maybe 2 years ago, I also experimentally tried to collect some micrometeorites using a magnet. This actually worked. I found round structures, very round ones. But one of the things is you have to be sure that actually these are really of cosmic origin, because sometimes if you're living in an industrial area, then there can of course be also very tiny spherical metallic particles from industry. So basically from Earth origin. Yeah? So, those the cosmic dust, those micrometeorites, when they're entering the Earth's atmosphere, they start to melt, and that gives them a very round shape that basically you can then easily identify with using a stereo microscope, for example. Yeah. So this is yeah. So a short question here: what is the use of using the plastic around the objective? That is to make sure that the lamp does not cast any hard shadows. You want to have a very even illumination, an even lighting. Yeah, and that's why you're using this plastic, like here, over here, around it to make sure that the lamps do not make any harsh or hard shadows. Yeah, so that's yeah. So thank you very much. I thought it was quite nice. Yeah, and. I myself am not so much into the search of micrometeorites, so I'm not an expert on this, but I know that there are lots of people out there who are really doing this in a very systematic way. I can imagine that, especially if you, unfortunately for us hobbyists, not possible, but if you've got certain electron microscopes, then you might maybe be able also to distinguish a little bit whether it's really from cosmic origin or from Earth origin. I think in industry, when you're doing welding and when you've got the sparks flying, then these can also produce very small round metallic droplets. Yeah. But right now, where I am living right now, I'm not in an industrial area, so it would not be likely to find those. Yeah. So this is something that I just wanted to share with you. Okay. So what else do I have here? Yeah, I think I covered pretty much all of the topics I wanted to cover, but I do want to show you something else, and then I would like to slowly go into the questions. Just a second. So have a look here. I'm going to show you now, and I'm going to switch over to the desk view because there's been a request again to do a little bit of a water observation, and look what I've done here. But it's not ready yet. I've got here some old pond water, lots of decomposition going on already, and look what is floating in here. I added a crushed starch grain. It did not sink yet. But it's been here now for 2 or 3 days already. And by adding starch grains, what you do is you're starting to grow basically protozoans, right? Because bacteria will grow using the starch as a food source. And then protozoans and other ciliates and whatever, they will start to feed on the bacteria. And also, of course, on the starch. And then you have a small food chain. And this is how I enrich paramecia, for example. Yeah. But as I see, there is not a lot yet, but you might see that there is, very far down, there is a starch grain that has sunk to the bottom. And what I'm going to do now is I'm just going to try to pick it out using my tweezers. Let's make a slide and let's see how, if anything is already growing in here or not. So I have done this a couple of days ago. I have to go all the way in. And I'm pulling out the bottom one. That's the bottom one here. And I'm dipping it here, and that should be enough. Okay, and I'll put this back. And a cover glass goes on top, and then let's see how successful this is. Okay, if not, then I have to wait a couple of more days. There's not a lot of water, what we've got here, so this might be quite compressed. But let's have a little check. So I'm going to switch over to the scope view again. Those dots are starch grains. The bubbles are spreading because of capillary action. The lines, the filaments here are the cyanobacteria, but honestly, look, I'm not seeing a lot of movement here. So this is definitely still too fresh, the sample. Let's get a better overview over the... there's a This is a nematode worm, what we have here on top. Yeah. So I have to give it a couple of more days, and usually it will go faster after a couple of days, because the growth is exponential. At the beginning, there's not much happening, and then later on, yeah. Unless there are really no protozoans in there, which basically I don't believe. Yeah. Yeah. So okay, so this basically means I'll have a look at it again again next week with you. Okay. Yeah. So, and those things here are basically starch grains. So now I turned on DIC to give it a little bit of color. Just a lonely nematode worm. The cyanobacteria, those filaments here that we see, which we've already looked at before. Okay. Yeah, I think we got to give it some more time. Okay. Yeah, so in a couple of minutes, I would like to answer your questions. So if you have any specific comments or questions, please feel free to post them. I hope that again today I will have my helper who is going to copy paste the questions and give me a printout, so it's easier for me to answer them. Okay. Okay. So here it's a nematode worm, and here it is. There has been, while I'm going to respond to the question later on, there has been a question if I'm ever going to write a book about microscopy. And the answer is, I actually already started writing one. And I started writing one, and however, yeah, I was not quite happy with the result, and I have to be honest. I will tell you what my problems are with writing books. It's difficult for me to find a proper target group. If it's a beginner's book, then I have to keep it simple, but then I'm not able to include some of the more advanced topics. If it's too advanced, then I might lose the beginners maybe. So I still haven't figured out yet for who to write the book for. That's the basic problem that I'm having. So I ended up writing several chapters, and then I decided later on, well, actually those chapters are way too detailed and too technical. Nobody's going to be interested in those. For example, in one of the chapters I've described in detail how phase contrast microscopy works, but then after I've read the chapters, I said, well, but actually the average microscopist really isn't, hobby microscopist is probably not interested in all these technical details. It should be more a book about nature observation, maybe, right? So I've been kind of going back and forth with myself and trying to find the direction a little bit, and this is basically where I'm stuck. Yeah. Then I also have started to write quite an extensive chapter on microscopes in schools, because I myself am a teacher. So I've been thinking, okay, maybe I should give some educational advice in the use of microscopes, but this is again a different target group. So you see, so that's a little bit the short answer. If you have any recommendations, please definitely feel free, to voice them. It will help me. But what happened is that I kind of wrote quite a few pages already. I think, I don't know, 200 pages of the book already, and then I kind of said, nah, it is not going to work. Then I started rewriting it again from the beginning. Yeah. Then I included some history of microscopy as well, and I said, well, actually, this is not really relevant if you want to do nature observation. So then I said, okay, maybe I'm going to just write a book about how to buy a microscope. And then says, yeah, but actually, this changes all the time, and it's because people want to have certain brand recommendations which I cannot give. So you see, that's a little bit where I've been going in circles. Yeah, yeah, So, the question here is maybe to show also more complex stuff. Yeah. So that's a little bit some of the things that I've been going back and forth. Yeah. Thank you very much. I did receive the questions now. Wow, it's even a little bit more than last week. Okay, so here are your questions. Here they are. We need to focus again. And I've not seen them yet, so I don't know if I'm able to give you a satisfactory answer or not. Okay, but yeah, I will try my best. And if your questions are missing here, then yeah, please, my apologies. Okay. How does the kid's microscope qualitatively compare to the microscopes that the researchers in the 19th century were using? It's an interesting one. And I will tell you why. Because the question is always the question of quality. What is quality? Back in the 19th century, I mean, that's what I found with my research as well. Basically, they have already reached the limit of resolution. So there has not been a huge jump, not a huge jump in microscopy, in optical quality, because the so-called the Abbe resolution limit has already been reached for a long time. So what the difference, however, is that the research microscopes, even of long time ago, if you look at very old pictures, you can see that some of the 19th century research microscopes were pretty advanced devices already, even with Köhler illumination, even with, of course, condensers, all of these things, but they must have been extremely expensive, right? But these things here, those children's microscope these days, actually, they almost cost nothing. So I would probably say it depends quite a bit on the actual microscope. And another thing that's really important is who's a researcher. Some researchers have been using fairly simple microscopes because they got their job done, right? And they were research microscopes, even though maybe there was maybe just one tube to look through, with maybe even only one objective, but for the task the researcher used, it was sufficient, right? So I'm basically say that the answer depends on what you understand with quality, because that's a very flexible term, and research actually means what are you using it for. And theoretically, and I know this kind of sounds weird, you can, for some things, you can also use it just a magnifying glass, right? And then it's also used in research. Yeah. So so these are the things, and I would probably say that it's a question of more of price. Yeah? And these days you're getting quite a lot of microscope for fairly little price. Yeah. How much was this camera? Megapixels. It's a 1920 by 1080, so it's basically full HD. Okay, so 1920 by 1080 pixels, and I forgot, it wasn't that expensive. Yeah, it was. Yeah. Sorry, I really don't remember, but what I will do is I'll put the link to the review. Okay. Yes, this was the Fleece Heart. Yeah, this was on the back. The Foldscope, similar to the cheap microscope but less sharp, or the same sharpness but with smaller field of view. Is it somewhat comparable? No. The Foldscope, okay, this one over here and this one over here cannot be compared at all. Okay, so this Foldscope is definitely not a replacement for a compound microscope. Cannot be, and was never meant to be. Okay, I would say the Foldscope are very basically, why I like the Foldscope is you got to take it for what it is, right? It is. I can imagine very good if you have, for example, school projects. If you want to get people, kids interested in microscopy, you can indeed use it to look at some slides. Yeah, and to see how the slides look like if you don't have and so on. So all these things are, but it's not meant to be a full replacement for a microscope. I know that in the Foldscope it has been said is that in the field it can actually be used maybe to identify blood parasites. Yeah, so basically in certain countries where you've got parasites and you need to establish a field lab for highly specific purposes, it might even be enough there, because if you put a blood smear on here and you're able to see certain parasites, then it's done its job, right? So I read that this is could have been also one of the the uses of the Foldscope. So highly specific uses in that sense. Yeah. I wonder why the Daphnias aren't moving. So basically, because they were kind of compressed between the slide and the cover glass, but not too compressed so that they're not going to die because of because of the force. Yeah. So this is always a danger. Yeah. Ever thought about writing a book? Yeah. Yeah, that's what I was just talking about. Not only thought about writing a book, but actually started one. And then, maybe actually, I'm thinking loud right now because I've been thinking, of course, about self-publishing it and doing all the layout myself. But because I actually already have a manuscript, which might need some reworking, maybe I'm just going to try the following. Maybe I'm just going to hire an editor to proofread everything and maybe to do, also the book formatting. Yeah, maybe this will also help a little bit. CA glue, I've not tried it, but I would not recommend it. CA glue is super glue for the reasons that I mentioned, that there are fumes that can actually deposit on the glass surfaces of the objectives. And I can also imagine, I don't know, that's something that I can kind of come into my mind. If I were to use CA glue here, what might happen is because of the moisture in the air, the humidity, it might start to become hard on the outside first, and then the center might remain liquid. So this is actually something, and then because it cures by reacting with the moisture in the air. And if the central part is kind of cut off from the moisture from the air, then I'm not quite sure if the CA glue is actually able to cure properly. Yeah? Looking from your permanent slides with PVA, I think I bought a bad batch of Elmer's. I don't have the results. I don't know. So the Elmer's PVA glue, that is used as the mounting medium. I don't know what the problem could be here. If you are a little bit more specific, and what does the bad batch mean? What I've done is I've diluted it a little bit with water, maybe about 15 to 20% of water to make it a little bit more liquid. But if you add maybe too much water, what's going to happen is the water will evaporate and then you've got bubbles forming because the glue will start to retract, and shrink rather, right? And this causes then also the formation of bubbles. So maybe that could also be an issue. Do I know about the Motic microscopes? I have a BA310E with Anzon filter, but it doesn't seem to work with oblique illumination. Can you share about this? I know Motic because we've got Motic microscope one in school, fairly advanced one. But again, I don't know this specific model here. At least, I mean, I know it from the name, but I've not used it myself. So if you want to try oblique illumination, what you'd have to try is try to use a dark field filter and try to decenter the filter. So this could be one thing, and also try to adjust the height of the condenser. Generally, if you're able to get dark field to work, then it should not be a problem to get oblique illumination to work. So this is something that I just generally can. I think it's something that you have to tweak around, and do not forget one thing: oblique illumination does not work well with low magnifications. So with a 4x objective, it doesn't work well. Try the 10 times or the 40 times objective. Yeah? So this is also something here, but doesn't seem to work with oblique illumination. Actually, I see no reason why it shouldn't work. Okay, you just have to make sure that the filter is decentered somehow. Sometimes they have a swing out filter holder or one that you can slide. Yeah? But if you try to make if you're able to get dark field to work and then you remove the filter a little bit by swinging it out, then you should be able to get oblique. Yeah. It would be nice to do some more project-like live streams, like when you added some of the caffeine to some Daphne, or when you squashed Ialosoma with air bubbles. Okay, I'm thinking about those. As a matter of fact, that's one of the reasons why I want to grow some more Paramecia, because I do want to mix them with some substances as well and see how they actually behave. Yeah. So there's interactivity here that you're kind of looking out for. Also, I would like to. I've done this already many months ago, because certain ciliates actually respond to electricity. So I've got a power supply, and I would like to show this to you again, because the ciliates, the Paramecia, will actually move along the field lines, and they will move, I think, towards the negative pole of the power source. I think a smaller diameter microtome will be easier to get some sample cut straight. Yes, that also might be the case. I've got another microtome which has a slightly smaller diameter, but I'm going to keep on practicing. Okay, yeah. So referring to this diameter over here. So this is on the other hand, this does have a little bit advantage that you're able to put in also slightly larger samples. I'm going to also try to work with paraffin, to do a little bit of paraffin embedding, and then maybe this also works. Yeah. I have maybe a 5 millimeter diameter micrometer, maximum 10 millimeters. I don't. Oh, okay. Okay. Yes. So basically, maybe the diameter over here. Yeah. I had the same problems with punching. I got better with turning the potato while pressing it against the punching iron. Okay. Thank you very much. This is actually an interesting recommendation. So when actually punching the potatoes, that you're trying to kind of maybe turning the potato or maybe the iron to, instead of just trying to punch it down. And then because if you punch it down, you might actually slide horizontally. Yeah. And this gives an uneven cut. Okay. So I'll try this as well here. So what's the use of the plastic around the objective? That was again referencing the picture with the micrometeorites. I already answered this question. The plastic is kind of like a diffuser, which kind of scatters the light so that you do not have hard shadows in the image. In cinema and photography, you call it a softbox. Yeah. Okay, so this is actually what sometimes also YouTubers use. They have those large screens right now. For example, I have a relatively harsh LED lamp here, right? And I'm directing it actually not directly into my face, but I'm actually directing this LED lamp here on my table, so that the table actually diffuses it back into my face to make less harsh shadows. Can you try observing phagocytosis? Yes, this is actually also one of the things that I would like to try in an upcoming video again, and that is phagocytosis by white blood cells. A couple of months ago, year ago, 2 years ago, I made some time-lapse videos of my own blood where I was able to show you some white blood cells doing phagocytosis. The disadvantage, however, is a little bit that this takes a long time. It takes a long time to actually see the white blood cells phagocytosing bacteria. So I have to really speed it up. So I don't know if this is a very good topic for a live stream, because you simply have to wait too long, but I might still kind of show you the procedure and then what I'm doing, and then maybe I've prepared a couple of videos where you're actually able to see the movement of the white blood cells. Amoeba also does this, of course. So in this case, if you have a water sample with some amoeba, then you're also able to see them crawl around. But then you have to feed them something so that you're actually able to see them swallow up certain things here. Yeah? Maybe you could try amplification and let it bask in the sun at room temperature. Okay. Okay. I don't know now to what this is actually referring to right now. Okay. Yeah. So. Okay. Okay. Or you can fill a jar. Oh, here we go. Next one. Or you can fill a jar with drinking water and I suppose you mean to say grass to observe paramecia. What you try to indicate here is making a so-called a hay infusion. I want to talk a little bit about hay infusions here, because I think you mean to say grass here, which is hay, dried grass. Hay infusions are a little bit of an issue. Hay infusion has been done back also in the 19th century. So what they've done is they've taken some water and they added some dried grass, and this started to then decompose a little bit, and you had bacteria forming. And then when you added some pond water, you also had paramecia and other ciliates and vorticella and so on growing. However, the problem with hay infusions like these is that it's really easy to grow a lot of bacteria. That's not possibly only a health risk, because you don't know what you're actually growing. But if you have a lot of bacteria, then the oxygen concentration in the jar drops, and then all of the other paramecia, and so they won't live because they're also going to die off because they need a lot of oxygen. Yeah. So generally, what I found out is that maybe hay infusions with grass and so on are probably not the best thing to do. Okay. One has to be a little bit careful not growing too many bacteria here. Yeah? Talking about nematodes, could you give a demonstration of a Biermann funnel? Yes, this is also something I was planning. And it's basically like this, that it is a way how you can also, for example, collect also not only nematodes, but also tardigrades and also other organisms. It's a funnel which is submerged half a little bit in water, and basically when organisms kind of reach the water, they will fall down and can be collected on the bottom with a test tube. Okay, so this is a way of actually concentrating microanimals. Yeah? So not too difficult to make, but I have yet to try it out, and all I can say is thank you very much for the recommendation, so I know what to work on now. Yeah? How do amoeba eat? I found videos of amoeba eating paramecia, but I cannot understand how they eat paramecia without the cover slip and in natural water. I don't know what this actually means. What do you mean, why the cover slip has anything to do with it? Basically, what amoeba do is they change their shape, right? They have a cell membrane which is flexible, and inside the cell you have a so-called cytoskeleton, which are protein fibers that are able to slide against each other, and this causes the shape of the amoeba to change. And this way it's not only able to move forward, but it's also able to engulf and surround the food. And then what happens is it surrounds the food, and then on the other side the membrane closes again. Yeah, and then the food, the paramecium or whatever is inside a food vacuole, and then enzymes will digest it. Yeah, so this can actually be observed under the microscope. Again, time lapse is better. And normally, what you do is you add a cover glass because you want to go up to really high magnification and you want to see this properly. And if it's beneath a cover glass, then also this limits the movement of the paramecium to the extent, not the paramecium, the amoeba, to the extent that it's not able to move vertically. So you're actually able to get a better image as it moves horizontally along the microscope slide. Yeah. So this is, so you could see it also without a cover slip, but with cover slip is better, and in natural water. Okay, without the cover slip. So let me try to understand this. I found videos of amoeba eating paramecia. I've seen those videos as well, but I cannot understand how they eat paramecia in natural water. I get it. Maybe you mean to say that if you have those amoeba, let me close the window because, just a second. Okay. There's currently the sirens are running, sounding because maybe there's a fire somewhere. So I think what you mean to say is how do actually amoeba, how do they feed if they're not on a microscope slide? Generally, you have to, because maybe on a microscope slide the paramecia and the amoeba are close together, and therefore they can be easily eaten. And in the natural water, what you have is you have those amoeba and paramecia usually on a surface. So usually rock surfaces or plant surfaces, the so-called the biofilm. It's a thin layer of bacteria and algae and also cyanobacteria growing there. And this is the place where you can also find amoeba and also paramecia a lot, because they like to eat organic material. So you will not find them so much floating around in the free water, but mostly they're associated to surfaces. Yeah, and that's why they're able to feed there. Yeah. Okay, maybe you could make a video on nematodes. I got a whole jar of nematodes standing over here on the window. I hate them, and I'm sure you will be able to make me like them. Oh yeah, I got a whole 2 jars of nematode worms, so-called vinegar eels. Those nematode worms are actually can be bought also for aquarium, because people who have a home aquarium sometimes grow them for fish food. And I've got them over here. They're growing in a little bit of vinegar and sugar. Yeah, so I'll do that. Maybe next time you could look at, compare, and discuss the structure of algae. I heard that they can be recognized by the cellular structure. Yes, and it depends. I mean, there's so many algae out there, and when you try to identify an organism, algae or whatever you want to identify, it's always a question to what level of detail do you want to know what it is, right? For example, I've shown you some cyanobacteria. I told you these are cyanobacteria, but it's a huge group, right? But if you're just happy with the term cyanobacteria, then you're fine. But if you actually want to know now which type is it, then you have to go into way more detail. Yeah? So as a general answer, if you want to identify algae or any organism, you always have to ask yourself is what level of detail are you happy with, right? And sooner or later, there will always be a point where you get stuck. Yeah, and then you probably are not able to identify them using the microscope anymore, but you have to probably do either biochemical tests or even DNA tests. Okay, maybe this is actually a good point. Let me quickly go back to because it's such a common question. Let me go back over here and let me show you again those bacteria that I had before. Because this is also in Reddit and in many forums, you always hear this, and I always say this, it doesn't work like this. Yeah. So look at those bacteria over here, and it doesn't say which ones they are. Look, I can show you this. I can just show you what's written on here. Bacteria 3 types smear. Great. I have no idea. Yeah. And it's a smear and it's stained. Yeah? So, but no idea what it is. And where is the scope view again here? If you look at this, okay, let me find a place. It's still too dark. Okay. Okay. So let's go up all the way with the magnification here. Okay, you see something like this, and then people want to know, okay, what bacteria are these? I have no idea, really. And are they dangerous? I don't know. Some of them look spiral-shaped to the spirilla or spirochetes, which can be found probably in which are water. Some of them are problematic, yeah. But there's so many different types of those. You see, just morphologically, that's the shape really doesn't tell you anything at all what they are. Or very little, at least. I mean, there's some specific cases. If you see some endospore forming, aerobic, bacilli-shaped bacteria, then it probably belongs to the genus Bacillus. There are some I'm getting technical now. So there's some highly specific cases where you can actually limit the possibilities, but otherwise, just by looking at it, you don't know because two bacteria look the same, have a similar shape or size, does not mean that they're also related. Yeah, and bacteria can also look very different from each other and be genetically very related. So both kind of goes both directions. And this is, I think, one of the problems of bacterial identification is that microscopes are quite useful for characterizing them, but they're rarely enough to actually say what it actually is. And that's something I just wanted to clarify because I'm getting quite a few questions where people want to know what bacteria are these, and I say, well, you cannot say that. You got to do DNA tests or chemical tests, and so on. But with algae, it's sometimes a little bit easier because they're not only larger, but there are also more details visible, right? So you can with algae and so on, we are actually able to get a little bit further. But sooner or later, there will also be a limit. Okay, on phagocytosis. Okay. So this is a request is phagocytosis. I'll try to figure out something here. Okay. So what I'm going to do now is as follows. I'm slowly going to call it quits for today again. I know that I'm quickly going through the comments section here. Maybe there are a few more questions or comments. Which did not find their way on the sheet here. Okay. So this is, okay, not for me. Nice nematode, okay. Talking about nematodes, could you give a demonstration of the Biermann funnel? Yes, I talked about that. Could make a video of nematodes. Okay, I'll make a nematode video. Okay, the structure of algae. Yes, I talked about that. Video on phagocytosis. Today okay. I would love if you could show or explain more complex stuff that you're, okay. Okay, I'll be honest with you. There are a couple of biological topics that I could actually talk about, but for example, my field of bacterial identification, something quite specific, right? But sometimes I don't have, how do you say, stuff under the microscope to show you that relates to the topic. So I can talk a lot about biology. There are many biology topics that I can really go into depth and talk about those, but sometimes it's difficult a little bit to find something microscopy related. So I'm a little bit unsure, and that's why I would welcome your feedback is to what extent am I not kind of, you see, if I start to make videos now on, I don't know, chemotaxonomy, which is the chemical classification of bacteria using chemical markers. I can do a video on that, but I'm kind of worried a little bit that I'm going to lose some of my viewers this way. You see, that's a little bit the worry that I have, where I'm a little bit torn between different sides. What should I do? On one hand, go a little bit more into details, but maybe I'm kind of going to lose some of the viewers this way. So you see, that's why I've been thinking a lot about these things as well. And I would appreciate your opinions on this. Yeah. So let me quickly go here. Some people talking in French. Okay, that's fine. I used to learn French long time ago, but unfortunately forgot most of it again. Okay, you can just order amoeba. Yeah, as a matter of fact, yes, microorganisms, some of them can be ordered as well, because they can also be used as fish food. More soil samples to know if our garden is in good health. That's a good question. I mean, can you actually determine whether soil is in good health just by using a microscope? I don't know, because what does good health mean? That's also a little bit of somewhat of a flexible term. I mean, is it that you're able to find many soil microorganisms? Is this the case? Yeah, it could be that there might be certain soil microorganisms present, but maybe that the soil is still contaminated with certain substances that are bad for plant growth. Yeah, so we have to be, I think, a little bit more specific here, but nonetheless, it is possible to observe basically microorganisms in soil, and if you find them there, then probably it's a sign that the soil is healthy. Maybe you make the difficult stuff on your other channel as videos. That's also possible. I mean, I've been also some organizational talk here. I don't know how I've got this channel here. I've got Microbehunter Microscopy, which is more the hardware channel, right? I've got a third channel that I abandoned a little bit. Is where I also tried to make videos. So I'm going to think about this a little bit, and it's going to be probably more like talking head videos, where I'm not going to add so many so much microscopy footage, but more explaining the things. Yeah. Stick with what you're doing, also a good one, okay? That's because if I'm trying to go off into too many different directions, then there's also the danger, of course, that I'm kind of not end up not doing something properly. Yeah. Okay, we found into a plant without chlorophyll. Interesting. Yeah. Could always add an advanced channel so people can choose to watch. Yes, I have to be, of course, always a little bit careful as well that I'm not going off into too many different directions, because making videos does take quite a bit of time as well. Yeah, garden soil versus dry, bad mineral dirt. Thank you. That's certainly something I could try. Okay, so people, enough for today again, I think. Thank you very much for your comments. I'm always happy to get a little bit of feedback so that we can actually that I know what to talk about. And where are just a second, I misplaced it somehow. Just wanted to check again how the Daphnia are doing, but I put them somewhere and I forgot where I put them. Yeah, here they are, and I hope that the water didn't dry out completely yet. So let's put them again on the microscope, and then I'm going to put them back into the jar. Okay. Here it is. Let me see. Yeah, you see, they're already quite, they've lost already quite a bit of water. Still alive, but you know what I'm going to do now is I'm going to add a little drop of water in any case. Because, yeah, I need to flush them back into the jar. Here we go again. Okay, now they're able to move a little bit more freely again. So I have to carefully remove the cover glass, and I'll put them back in. So yet more water. See, now the other one also starts moving again. Yeah, they have now a little bit more freedom. Yeah. So it is pretty perfect as it is. You have different topics and levels, include one live stream, and for me that's wonderful. Okay, thank you very much. Also important feedback. Sometimes it's good to be also reassured. Yeah? I'm going to now leave it at that again. I hope to see you again next week. I of course also keep on uploading some regular videos to this channel as well. Please do have a look at those as well if you're interested. And I'm going to just say goodbye for today again, and wish you all the best. Happy microbe hunting, and as always, and see you again. Bye bye.